Okay, jetzt kriegt man gerade nochmal das FT-Ding, oder? Das ist gleich ein Teil. Ja. So any questions so far for protocols? No. That's good. So in my country now we have 5 o'clock. I have to do 10-minute breaks because my voice will square angles can be made from granite, steel or concrete. For precise measurement it's important to have accurate frames and bars and everything. But, so if you use some frame, so every frame has normally also a protocol that will be delivered with it. So then you have some description how good is your part. And here we have a measurement protocol of our stone frame that we have here at the academy, and that shows the squareness, the perpendicularity and the parallelism of that sides that will be shown here. So maybe in that case we see the C here, C to A, that are the deviations that the frame has. So that normally is also being checked. So stone frames, if they don't fall down or will be hit or something by hard things, normally they are very stable and very, they are not worn out with something. Depends here if you have a steel frame, so that can be, if it fall down or something, that basic tolerance is gone. So then in Germany normally we have it necessary here that all measuring parts will be also measured year by year, or some timetables that we have to bring it to measuring rooms, that you have to know your equipment is fine and in good conditions. So there only one hint how to look for it. So the other ways, if you use a part like that, you can measure it with a reversal measurement. So then you see that failure, I can calculate within, or also to be checked with a reversal measurement before you start your complete cross angle measurement or something. That's important thing to do before you start a machine check. So in that PowerPoint we see measurement error part 2, cross angle measurement. So in that case we see, I will show you some different machine types that we have here at the plant. So in that case we have a tour block, a sketch, and you see the coordination cross, and also this coordination cross is our cross angle for the machine. Also here described which axis turns around, this round axis turns around the x-axis. So always good to know. So cross angle measurement. Is to know where are the positions, where are the basic, and also where are the guideways, the rail guides. So there you see that angle that we measure here on the table. That's the angle here from the, I said, hour to machine bed. Oops. They are the basic for pressure measurement. So the cross angle has to be in a tolerance condition. Then you can continue with measurements of C-axis, B-axis, or if you have an A-axis also. So here we have a cross angle, and this is a machine type. That's a new machine, I think now, 2 years ago now in Pfronten plant. That means that is a monoblock H machine, and that has a different coordination system. You see, now the vertical axis is the y-axis, the horizontal axis is the z-axis. We have, in that case, we have a little portal, and also we have a gantry axis. That means we have in the vertical side y-axis 2 ball screws left and right. So then we had the portal machines. That means here like monoblock H, or we have the big ones. Where is it? What is the? Or we have the big ones. This is the biggest machine that we built here at the plant. DMU 600. I didn't know if anybody see that machine. But also same system. We have a portal in a vertical axis. In that case, cross angle is, in that case, I think also z-axis. Or vertical axis is z-axis. But back to the monoblock H. Monoblock H, maybe we go, you see the sketch here. The monoblock H has, I said, a gantry axis here in Y with 2 ball screws. Linear guides outside here. And but in this sketch, you see the table is outside the center of the portal. So we have a swivel round table, like A-axis and Z-axis. And another big difference that that machine has is the 0 point is the Z-axis, the machine 0 point is here. Not like described on the monoblock before. So that's a big difference at that machine. Yeah. This sketch is a little bit, maybe confused. Huh? That's the looking of from the side of the machine. We have here the swivel round table, y-axis with a gantry, horizontal axis is the z-axis in that case, and also the cross angle to know it's the same. Basic is the table, and therefore we have to look the conditions like on every machine x to y, x to z, z to y. Same thing on every machine. It was a Madonna. Yeah, cross angle on. That's the sketch of a portal machine. Portal machines, we had older ones from the DMU 200, 210, 270, 340, up to 600, the biggest machine that we built in the DMG Mori company. But at the end, it's always the same on every machine. Small machine, big machine, maybe the deviations and the tolerances are sometimes a little bit bigger, but not much. Yeah, different is to maybe to remind dual block, the basic axis is y-axis. That means if we had a problem, geometric deviation in the cross angle, the y-axis is the basic and we can't adjust. You can adjust it, but you don't adjust it. Adjustment is to the other axis, X and Z in that case. So, and here we have a sketch of a monoblock machine. Also you see cross angle, same like here, but you have also, yeah, one thing is to the monoblock H. There can be the, let me quick press the split for the monoblock H. Yeah, there is a lying down monoblock. If you see, and there is only change the coordination cross. And that machine is available with two kinematics. There is a kinematic of AC. That means the 0 point is, looking mal wieder was Bestes up. Just a moment, I will look for a better description of the monoblock H. Is there anybody there who knows a monoblock H machine?
I haven't personally worked. Well, there's like a minor electrical issue on it, but I've seen one in the wild before. Pretty cool.
Okay. Yeah, machine is not bad, but it's a little bit different than the monoblock and also different than as the dual block machine. But I will show you some description.
The spindle is a little bit harder to change in those machines, that's for sure.
Okay. Yeah.
What do you mean, just as far as like keeping it in and out horizontally? Is that what you mean?
Yeah, it's a little bit, you have to like strap it to the table at the right height, or you can then move the y-axis out and pull it out of the cavity that way.
So there is a little bit. So sorry, but that description is in German, but only to see. Yeah, that description is with table. So if you have the machine is available for the customer with an AC kinematic and an AB kinematic. And that means if we have a condition like in that sketch, you have an AB kinematic. That means the coordination cross is changed, and we have the vertical axis, as we know from monoblock, dual block in Z. If you have an AC kinematic, so there is the kinematic. In AC kinematic, we have the table in vertical position, and the coordination cross is changed, and the vertical axis is the y-axis, and that's the standard delivery from that machine. If you like, if the customer like it in AB kinematic, because he has a lot of horizontal machines in the past in his plant or something, and he has some programs that to be run on that machine also, then he has to order that machine in AB kinematic. So that's the big difference in monoblock H machines here. But if the customer has quite a machine in any kinematic AB or AC, it is not changeable. So you can't switch the kinematics if you like. So this is not possible. He has to use that kinematic that he buy. Here a little picture that is B kinematic. Stimmt damit. Weil dann müsste Z eigentlich der Ober sein. And that's an older picture. That one is from the this is AB kinematic. Yeah. Maybe other pictures of the machine. At the Epsilon. Weil jetzt kann ich mal nicht. Ich weiß jetzt nicht genau. Ich habe keine Bilder. Der
Maschine schätzt das synthetische Patienten.
Yeah. But normally, yeah, in our training, I think tomorrow we have the dual block machine, and also it is settled up of the dual block, this training. And we have to use like that place, and the y-axis here is in that one the basic axis. So what's there on? Manipulation. Yeah. Sparapramid. Spec. So da. Haben wir da? Dual block. Here, font, picture. Das ist really not right. Sorry guys, just a moment, I'm looking for a description of the dual block machine. Yeah. Oh, it is it in English. Das muss ich nochmal besser sortieren. Auf Deutsch. So maybe first. Yeah, now I will show you a design of the Z-axis at the dual block machines. So Z-axis table, yeah, that's the standard table that we normally use at milling machine. So there we have a couple of options. So we have also milling and turning option on the dual block. Our machine that we do the geometric tomorrow is also with milling and turning availability, but at the end the axis is always, the design is nearly the same. Here we have a gearbox for the normally NC1 table, standard 1 table, table plate for connections to the linear guide shoes, and some technical data we can use here. So, and what I will show you is Buschensgetriebe. Das ist Getriebe. Nee, wat denk nog? Dat is Lager zien. So, and yeah, if we look at that drawing, you can imagine we have our console here, and inside the console we have a big gearbox and gear wheel, and on that side we have mounted the plate with the bearing, and that is one case that we have. If we have a crash or a collision or something, then we have a tension in the bearing. It means this description of so the bearing is mounted on the gear wheel on the plate. This is not the right drawing, I should look. Yeah, here is better. This is normally a lubrication, but you see here is the bearing inside. So, and if you imagine we have a collision here, influence with a force anyway, so then we have a tension inside here. And you see here we have plugs and holes. We come to the connection screws. Maybe I will do this a little bit bigger. Is it better now? I think so. Yeah. We see here the bearing connection, and you have to go, if we have, you measure out and run out, out of tolerance. I think for me it's a thing that I said the tolerance here is described sometimes at 16 microns or 20 microns, but from the experience way, don't go over 10 microns run out on the dual block machines. So, and if you are run out over 10 microns, measured by, I think, range 400 millimeters in the diameter, or 300, then more, 150, I think, they will be measured out the run out. So, if you have a big deviation like 35 microns or something, for example, then you have the first thing is to bring the tension out of the bearing, and the bearing connection is mostly the weakest part at that design. And then you can lose every screws. I think around 36 screws are in complete on the bearing. So then you have to move all 10 degrees the cable and to release and retighten all the screws. So also maybe if you can release it, I know from experience they had stress it out overnight. So that means open it and stress it out with some hits over with a rubber hammer or something on the table surface, so that we have some tension here and to bring this tension out. And after then, you have retighten our screws here, left also complete roundness of the bearing. Then on the most parts, you will see that the runout is in the old condition. So if the bearing is worn out or something, you have to replace it. That's clear. But normally at collisions or crashes, mostly we have a tension in that bearing. Yeah. Hast du jetzt auf? Mit Tourblock. So the next special thing on the tour block machine is